Good evening, my dear students. Jai Hind soldiers. How are you? Yes, very fine. I am also fine and expecting that you are completely rocking in physics and doing every day at least 20 questions. See, always have a commitment with yourself that if I want to be good in the physics, just you have to solve minimum 20 questions every day. Just solve 20 questions and after that have analysis of all these questions, whatever mistake you have committed, and just try to improve that type of the mistakes. Definitely day by day you will get improved. Yes or no? And whatever questions you are doing, whenever getting difficulty, that time don't get depressed and don't think negative. Always think that yeah, I am here to learn something. Always you should have excitement to solve question. Like whenever we are playing any sports and we need some specific tricks. So that tricks means we want to learn how to deal with these types of the ball, how to deal with these types of the shot. So this is the process to learn the physics. That's why always my VS soldiers should be highly motivated with complete fire. Very good. E equal to MC square. Good evening Ajay. Good evening Sonali. Hello. Hello Sonali. Hello. And good evening. Yes. Good evening Venkat. Good evening. Ele Mundu Inka what? Ele Mundu Inka si. Okay. Good. Very good. Done. Asif. Nenu. Vachesa. Okay, done. Whatever you written, I think you are writing good for me. Thank you for my appreciation. But I don't know meaning whether you are appreciating me or doing something negative words. Whatever it may be, students' negative word is also always appreciation for the students. Because if we are expecting goods, that means we have to expect some evils also. That's why don't be worried whatever goods and bad comments you are giving. Every day expecting, or you can say I can accept everything, don't be worried. But the thing is, again, I am telling you, the Sri Chaitanya group doing for you, that is really the wonderful. And I think you enjoyed the journey, whatever facilities provided to, and you, I think, completely make your mind to take admissions in, yes, especially in Gosala. Yeah, that is the best environment, the best discipline, the best faculties, the best rank producing, as well as the best management. Everything is the best for the students. Everything is to be done for favorment of the students only. That means betterment of the students only. That's why those students who are thinking to take admissions in this campus, definitely they will feel enjoy and will get you can say fantastic result in 2027. So that's why be ready for that. We always with you. Okay, let us, dear students, start with our topic. Viewers, I think yesterday we discussed about the unit and dimensions. Unit and dimensions means, okay, let me revise something. Yesterday I told you that this is basically the first chapter of the physics in which we are going to discuss about various types of the physical quantities. So that's why in you can say most of the dropper batches this chapter is you can say to be teach at the end of the syllabus. Reason is that at that moment students are able to understand each and every quantities. But right now I think you are aware, because right now if you are you can say watching this bridge course, physics, chemistry, whatever you are studying, that means you know something about some physical quantities, like what is velocity, what is acceleration, what is force, what is work, what is impulse, yes or no, what is angular momentum. If you don't know, don't be worried, I will tell you, I am always here to assist you guys, don't be worried. Okay, so students, let us start. Our main topic for today is very, very important, that is dimensions. So before going to dimensions, those students who are new in today's class, I think no one is new, everyone is taking, all my old soldiers, yes or no, and every day enjoying the physics. But especially, again, I want to revise. In today's class, you can say the things which you should know before starting this class. What is that? 7 fundamental quantity, 7 alphabet of the physics. Means by using these alphabets, we can make all the quantities of the physics. Means to say, whenever you went in your school, in your nursery sections, initially your English teacher taught you about the alphabets, A for apple, B for what is that? Very good, B for boy. And by using that alphabet, you are able to make your spellings, words, sentences. In same thing happens in physics. First, we are going to discuss the alphabet of the physics, that is called fundamental quantities. How many? Note 26, that is 7 quantities. M, L, T are very, very important. Mass, length, time, then after current, Kelvin, temperature, mole, this is chemistry part, then after luminous intensity in the sense candela. I think 4 is over. sorry 7. These 7 are the fundamental quantities. Means by using these 7 quantity, all the quantities in physics can be derived, and that quantity are called derived quantity. But 2 supplements are required, 2 more supplements required, that is called supplementary quantity. Yesterday I told you that supplementary quantity is, what is that? That is radian and steradian. Which one? One is radian and second one is steradian. I think you know that. Don't be worried. We no need to study much about the radian. Radian, you know that. What is radian? Okay, let me explain you first this part only. Radian in the sense, you know this angle. Whenever a particle moving in angular path, this is radian. Angle. Which angle? Plane angle. 2D structure. But whenever you are moving in 3D structure like that, this is 3D structure. Then is this 3D, this angle, this 3D angle, this is denoted by d ohm, in the sense steradian. This is solid angle. Steradian is the unit of which angle? Solid angle. Only one name, that is indicates for which one? Supplementary quantity. And don't be worried, in our syllabus we don't have much about this solid angle. I think previously before 2011 there was some part that is in your second year physics, electric flux, we need this quantity, but right now whatever syllabus is being designed, no solid angles you can say requirement is there. You just know solid angle is supplementary quantity and its unit is steradian. Yes or no? Now our today's topic is, what is that? Dimensions. What is that? Dimensions. Means to say, by using all these 7 fundamental quantity, the derived quantity can be derived, and that equation formed in terms of fundamental quantity are called which one? Dimensions. Let us assume we are taking example. Yesterday also I told you, let us assume we know the force. What is force? Yesterday we have discussed that. We know that if we want to represent force in terms of fundamental quantity, how to denote? Sir, we know that force equal to mass into acceleration. Mass is equal to m. Acceleration in the sense length upon time square. Only I am using units. This is meter per second square. Then it is going to be m1, length for L1, t for t minus 2. So what is this? This is the dimensional equation. If someone asks you what is the dimensional equation of the force, m1, L1, t minus 2. How to read this statement? Dimension of force in mass is 1, in length is 1, in time is minus 2, and this complete part is called dimensional equation. So let us form number of dimension equations. How to form dimensions? Very important part. Okay, so let us start. Okay, I think you know about the force. What is the dimension? Already we have discussed m1, L1, t minus 2. Now you tell me, and you start making this dimension. W for work. What is dimension for work? See, those students are not comfortable in these quantity. You should know how we can denote the work. Work in the sense force into displacement. How to write work? Work equal to force into displacement. We know the dimension of force already. What is the dimension? m1, L1, t minus 2. And what is displacement? Displacement is L1. That means what is the dimension for work? m1, L2, t minus 2. You can remember also. And one more thing, work having same dimension of energy also. That's why dimension of energy is also same. One more quantity we will discuss. Yes or no? What is that? That we will discuss later. Same quantity, that is called torque. What is that? Torque. If you know torque, torque is force into length only. Means dimension wise these quantity, these dimensions are same. Note the quantities are same. Means to say, if 2 or more quantities having same dimension, it doesn't mean that these quantity are same. See, torque is entirely different as compared to work and energy. Even though work and energy are somehow relevant to each other, but torque is entirely different. Yes or no? So that's why it doesn't means that if dimensions are the same in the sense quantity are same. No, these are the different quantity. Yes or no? Up to here everything is clear. Okay, let us move forward. If someone asks you dimensions of power equal to, we know that work upon time. Dimension of work we already discussed, m1 L2 t minus 2, and time is t. What is complete dimension? m1 L2, when t going upside, this is equal to t minus 3. So this is the dimension of power. I think you are getting this. You know that sometimes, sir, we know the formula for the power equal to F into V. That formula also you can use. You will get the same dimensions only. Don't be worried. Yes or no? Okay. Do it fast. Done. And I think up to here everything is crystal clear. And you people are making notes or not? If not making, yes, try to write whatever things we are studying. These are very important for you. Very, very important. Yes, sir. Okay, dear student, let us move forward. Now we are going to discuss some more quantities, dimensions. Let us assume, take example. If someone asking you dimensions for momentum, so you should know what is momentum. Momentum is denoted by letter P. This is vector quantity. And momentum, what is momentum basically? Momentum means, momentum is the only quantity which can define the motion of the particle. Sometimes this question being asked, whether motion is defined by velocity or momentum. It is defined by momentum only. See, if someone asks you, see, this is very important question and very confusing also. Someone asking you means to say motion can be defined correctly by using momentum or velocity, not by momentum. Because if you don't have information about the mass, that means we can't say how much strong motion is there. Let us assume I am saying that one body is moving with 1 meter per second, another body is again moving with 1 meter per second. Can you stop that body? Yeah, very important. Then question will come, sir, what is that body? What is the mass of the body? If one body is, let us assume, 1 gram stone, yeah, definitely, sir, we can stop. But if that is, you can say, train, something very heavier object, we can't stop that. So that means very, very important. Momentum can be defined. Momentum can be defined the motion, very, very important. And it is product of mass and velocity. Dimension for mass is m1. For velocity, L1 t minus 1. That means this is m1 L1 t minus 1. This is the dimension for momentum. And similar to momentum, one more quantity, that is called impulse. Impulse is also having same dimensions. Very important. You need to remember, whenever this types of the question is being asked, you to be ready how to solve these concepts. Yes or no? Okay, let us move forward. See, yesterday I told you one quantity, very important, that is angle. Angle in the sense that is called angular displacement. Very important, dear student. Be very, very attentive. Very important concept. Angular displacement. Angular displacement is denoted by theta. And its unit, I already told you what is the unit. Sir, unit is radian. And how to define angle? Angle equal to, from childhood we know that angle equal to arc upon radius. What is arc? Arc itself taken in length means meter. This is also meter. Meter upon meter cancel. That means this is going to be m0, l0, t0, means no dimension is there. Wherever dimension is not there, no dimension are there, these quantity are called dimensionless quantity. Which quantity? That means there are some quantity which are dimensionless. So dimensionless means all the power is 0. There is no weightage on any of the quantity. That means these are dimensional quantity. One more important statement is there. See, theta having unit radian but don't have unit. That means we can write one statement. It is not necessary that a dimensional quantity is unitless also. Very important statement. You can write it. VS note. Very important note. What is that? Dimensionless quantity. Very important. Dimensionless quantity may have unit. But unitless quantity always dimensionless. Very important statement. NEET statement directly. That question is being asked in our exam. Now you read this and try to understand this concept. Very important concept, dear student. Very important. Again, comment box should not be used for chatting. It should be used for our physics discussion only. And even some of the students writing in Telugu, I don't understand whether you are something positive comments, negative comments, or you are doing something friendship like that. No, these are not allowed for you students. See, in education, I am always telling you the things that is required to become successful. That is discipline. Respect towards your teachers, your parents, your elders. That is required, dear students. So especially in this coming generation, these things are the missing. That's why if some parents also listening me, I request them always guide their kids what to be disciplined. Very important, because that will be helpful for all of the, you can say you as well as the society also. That's why if kids are the disciplined, they will learn something. Without discipline, it is not possible. Yes or no? That's why nowadays this, I think no need to tell me all these things. Okay, dimensionless quantity may have unit, but unitless quantity always dimensionless. For example, what example I have given to you? For example, what is that? Angular displacement or angle. Any other example you know, then tell me. Angular displacement. Any other? Which one? That is called angular displacement, or you can say angle also. Second one I told you, what is that? Solid angle. Steradian. Yes or no? Solid angle I told you. That dimensionless, but its units have which one? Steradian. Very important. So you should remember this concept. Okay. Up to here everything is clear. Okay, let us move forward. Let us move on some different quantities. Different in the sense, I think you know that force between two mass m1 and m2. This is very important parameter. This is mass m1. This is mass m2. Distance between both the masses is r. What is this force, dear student? This force is gravitational force, always attractive in nature. And value of this force is going to be g into m1 m2 divided by r square. Now my question is that this g is called universal gravitational constant. What do you mean by universal? Universal means it is not going to change anywhere in this universe. That is universal gravitational constant. And why I am telling you? Because in NEET exam, most of the time this G word is used in unit and dimensions. That's why my dear students should know what is the dimension of G. Find it out, because formula is in front of you. I think now you are capable to make the dimensions. Sir, G equal to F into R square divided by m1 into m2. I think this is the formula. This is G, F R square divided by m1 into m2. Now you try to do it. What dimension it will be? Do it fast. How to find dimensions? Yes, very good. Force dimension we know that. M1, L1, directly remember T minus 2 because force dimension very important. R square in the sense meter square, L2. Mass in the sense M1, M1, M2. Yes or no? Now mass power 1, when this is going upside, this is minus 1. L1 and 2 is there, this is L3. This is T minus 2. Yes or no? Very important. No need to memorize these dimensions because these are very lengthy tasks. So that's why you should know how to form these dimensions. This is the important concept and very simple also. If you know the formula, you can able to make the dimensions. So I think you are comfortable in these dimensions. Yes or no? Yes, then yes, comment box should be filled with complete of energy. Okay, let us move forward. See, in same concept, this is gravitational force. One more force that you will discuss in which one? Electrostate. Whenever two charge. Okay, before that, if I am asking you what's about charge, what is the dimension of charge, how to find out? Let us move on some current electricity part. What is the dimension of charge? Can you find that dimension? Try to do it. What is the dimension of charge? How to find out? To make the dimension of charge, see, sometimes students are confused that charge is basic quantity, means fundamental quantity. No, charge is not the fundamental quantity. We know that current I equal to charge upon time. Charge is denoted by Q. I think you know that. That means Q equal to I into T. Now these both are the fundamental quantities. That means charge can be denoted in terms of A and T. Then what will be the dimensions? Complete if we want to write out M is 0, L is missing, T is 1 and ampere power 1. This is the dimension of charge. Remember this. Very simple and very important also. I think you are able to do this. Yes or no? Okay, this is charge. Now if you know about the charge, then tell me about like gravitational force, we having one force between charges Q1 and Q2. This force is called electrostatic force. I think you know that if two positive charges repel each other, two negative charges repel each other, one positive and one negative attract each other. So on the basis of this one, we can say if distance between these charges is R, force between this is K into Q1 Q2 divided by R square. This K is constant. K is constant. And value of K is defined by 1 by 4 pi epsilon naught. Now we are interested in this epsilon naught. What do you mean by this epsilon naught, sir? Epsilon naught means this is electric permittivity. What is this? Electric permittivity. You remember this is very important that you will discuss in electrostatic parts. Now my question is that you find dimension of this electric permittivity. What is my question? Find dimension of epsilon naught. You do it by yourself first. Try to do it. Very good. How to calculate these dimensions? I think you done. Okay, let us move on next slide. What was our formula? Formula is given by F equal to 1 by, can I write K equal to 1 by 4 pi epsilon naught? Then Q1, Q2 upon R square. Don't be worried, I will tell you shortcut also. But first, you should know how to find the dimensions. In this case, the dimension of epsilon naught we need. That's why take epsilon naught this side. This is epsilon naught. Epsilon naught can be denoted as epsilon naught that side, F will be this side. That means charge can be written as Q square because we are interested in dimensions only. Q1, Q2 both are having same dimensions of the charge divided by force will be this downward side. R is R square. Now write down their dimensions. Charge, we know that A into T, square means both the squares. Now force dimension M1 L1 T minus 2, R square means L2, yes or no. Now find this dimension epsilon naught is going to be mass when going upside, this is M minus 1. Length L2 and L1 when going upward side L minus 3. T minus 2 and T2 upside, that means T power 4. Am I right? T square and T plus 2 means T power 4. L minus 3 is over and A2 is already there. So this is the dimension of epsilon naught. And tell me how many students are right in this dimensions. I think you got that. Yes or no? See, this is your second year physics part. So that's why solve this by using your logic. Okay, do it fast, dear student. Okay, let us form another dimension, very important. See, in the same way, this electric part, second, see, first we will discuss some quantity about electric part only. Don't be worried. Most of the quantity I will tell you how to form the dimensions. Now, very important, you know electric potential. You know Ohm's law, in Ohm's law, resistance and electric potential, both are very important. That you call voltage. Electric potential is denoted by V. How to form this dimension? Sir, electric potential equal to, those students don't know the formula of potential. Electric potential means, if we want to bring a unit charge from infinite to at particular point, that is called potential. That means work done divided by charge. This is the definition of potential. And you know the dimensions of work done. What is that? M1 L2 T minus 2. What is dimensions of charge? A into T. That means dimensions of the V is M1 L2 when T going upside, this is T minus 3, and A going upside means A minus 1. This is the dimension of potential, dear student. Directly remember, this is the dimension of potential. See, no need to memorize these dimensions. You should know how to form these dimensions, how to make these dimensions by using fundamental quantity. Now, if you know this electric potential, another quantity you know that, very important, electric resistance. What is that? R. R stands for resistance, or you can say electric resistance. I think every student know that V equal to IR, we know that. This is Ohm's law. As per Ohm's law, R equal to V divided by I. Yeah, we know the dimensions of potential. This one is the dimension of potential. Just divide it by I only. I stands for A. That means when we using this dimensions of R is M1 L2 T minus 2, and this is A minus 1 is there. 1 minus will be upward side, A minus 2. Yes or no? M1 L2 T minus 2 and A minus 2. This is the dimensions of electrical resistance. I think you are getting this. Very important. Very good. Charan Chari, yes sir, good, very good. I think getting it. Yes or no? I think you are enjoying also. See, most of the quantity, then it is made that you should utilize your time. See how to form these dimensions, what is these quantities, because all these things you will study in detail in physics only in first year and second year part. That's why be very, very attentive. Okay, you know dimensions of potential, you know dimensions of the resistance. Okay, let us move to the next part. In current electricity only, you know one part that is called capacitor, capacitance. What is that? Capacitance. Capacitor, you know that the quantity is called capacitance. It is denoted by C, and formula for C equal to Q divided by V. Q for charge, V for potential. You know charge dimension A1 T1, A into T. Already discussed, yes or no? And what is dimension of potential? M1 L2 T minus 3 A minus 1. What is this dimension? M1 L2 T minus 3 and A minus 1 or A minus 2? Yes, A minus 1. M1 L2 T minus 3 A minus 1. This is the dimension of electric potential. That means capacitance can be write as M going upside minus 1, L going upside minus 2, T1 this is going upside T minus 3. Yes or no? Not T minus 3, T plus 3, sorry, because L minus 2 T plus 1 is there, this is going upside, this is plus 3, not minus 3. Then after A, 1 is already there, this is going upside, this is A2, yes or no? This is dimension of capacitance. See, you check it whether you are able to understand it or not. If you are able to understand, yes, then comment box to be fired with lot of energy. Yes or no? What is that? In resistance, T is minus 3, maybe. In resistance, what we have write? In T minus 3 or T minus 2? Yes. What is T I have written? Potential V, T minus 3. Yes, this is misprint. Yes or no? Very good. They will, whatever name is, yeah, some of the students are observing very well, very good. See, in this one, this is the T minus 3, now V only, T minus 3. T is not going to change, T minus 3 only. Very good. And this is T plus 3. Good, very good. Okay, let us move forward. Now we know the capacitance, we know the resistance. One quantity is also there, that is called electrical inductor, that we will discuss, don't be worried. But before that, I want to discuss some more quantities. These are related to temperature and rotational motion. In rotational motion, I told you about some quantity, which one? That is torque, very important. I told you that about torque. Torque means, this is the moment of force, denoted by tau. This is force into perpendicular distance. If someone asks you, what do you mean by torque? Force into perpendicular distance. What is force? Force is denoted by M1 L1 T minus 2 and length itself is going to be L1. So this is M1 L2 T minus 2. This is the dimension of torque. And I already told you this dimension is same as dimension of work and energy. Very, very, very important. Another quantity, you are having pressure. See, this quantity, you know that. Yesterday I given you task that you should read. I think you studied all these quantities. Pressure is denoted by P and definition of pressure equal to force divided by area. Dimension of force, we already know that this is M1 L1 T minus 2 and area is denoted by L2. Yes or no? Then this dimension will be M1 L2 going upside L minus 1 and T minus 2. This is the dimension of P for pressure. This is the dimension of pressure. So you should remember these dimensions. Yes or no? Can you tell me which quantity having same dimension as pressure? Can you tell me? Yeah, one quantity that you will discuss in your first year part only. What is that? That is called stress, or you can say second. See, dimension wise I am writing. Those quantity are different. Stress is something different, but that is also force upon area. So you can remember that pressure and stress both are same as dimension is concerned. Very, very, very important. Yes or no? Okay, let us move. Sometimes you find some questions in which it is mentioned that which of following quantities are dimensionless. What can be mentioned? Which of following quantity can be dimensionless? So let me give you some example. I think you studied about relative density or density. Okay, first discuss about density. If someone asks you what is the dimension of density? What is that? You tell me fast. Let me check whether you are chatting only or you are studying also. Okay, tell me what is the dimension of density? Tell me fast. Yes, dimension of density. Density is denoted by mass upon volume. Dimension of mass we already know. This is m only. Volume means L power 3. So this is m1, L power minus 3 and T power 0. This is the dimension of density. But what I ask you that if someone asking you about relative density, which density? Relative density. What is that? So relative density is defined as relative density is equal to density of that liquid divided by density of water. You know this definition. And water at 4 degrees Celsius. Don't be worried. We will discuss all these things in fluid. Right now, you should know what is the formula for that. So that means if someone asks what is relative density, you can say relative density is basically a ratio. What is that? That is a ratio. So when you find out this dimension, both are going to cancel out, means m0, l0, t0. What is meaning of this one, dear student? Very important. I already told you, and this is very important for NEET exam. Whenever no dimension is there, that is called dimensionless. That is called dimensionless. And you can observe that this quantity is dimensionless and relative density doesn't have any unit. That's why unitless also. So this is dimensionless as well as unitless. What I told you, very important statement is this one. What is that? Dimensionless quantity may have unit or not. Yes, definitely. Not must have unit, may have unit, may have, may not have. See, this is dimensionless but not have unit. We studied the angle and solid angle. That is also dimensionless but having unit. But unitless quantity is always dimensionless. This is very important statement. Just remember this statement. This is NEET. You can say very important part from where question is being asked. So this is about density and relative density. Okay, now let us move forward on these some rotational mechanics quantities. I already told you angular displacement. If someone asks you find angular velocity, what is that? Angular velocity. I already told you it in which one? Circular motion denoted by omega. What is the dimension? To find this dimension, sir, we know that omega equal to d theta by dt. See, d theta means angular displacement. This is dimensionless. m0, l0, t0. And this is t for time, t1. That means dimension of angular velocity is going to be m0, l0, t minus 1. Remember this. And its unit is radian per second. What is unit? This is radian per second. We already discussed this quantity. So that's why you remember, whenever we want to find out dimensions of the which one? Rotational quantity like angular displacement, we already know dimensionless. Angular displacement means angle only. And angular velocity means displacement upon time. In same way, you tell me the dimensions of angular acceleration. What is this dimension, dear student? Sir, angular acceleration is denoted by alpha. And what is formula? We can say this is d omega divided by dt. What is omega? Omega we have already discussed. This is the angular velocity. And time we already know. So that means this is m0, l0, t minus 1. What is time? Time is t plus 1. This is going upside. m0, l0, t minus 2. This is the dimensions of angular acceleration. Very, very, very important. I think, dear student, up to here everything is clear. Now let us move. We have discussed angular displacement, angular velocity, angular acceleration. One more quantity that is very important in this rotational motion. What is that? See, in translatory motion, whatever work is performed by the mass, same work, is its replacement in rotational motion is called moment of inertia. What is that? Moment of inertia. And moment of inertia is denoted by I. Moment of inertia means, you should know also, what do you mean by moment of inertia? Moment of inertia means whenever you want to rotate any material, any body, let us assume we want to rotate this fan by our hand, what? It try to oppose that motion. That's why that oppose is called moment of inertia. Heavier the mass, heavier will be the moment of inertia. That means this is denoted by mass into perpendicular distance square. Don't be worried, that also you will discuss in rotational motion. Right now you just know the formula so that you can form dimensions of that quantity. That means moment of inertia is m for mass m1, this is L2 and T is 0. This is the dimensions of moment of inertia. And one more quantity in rotational motion. This is last quantity for today's class. Rest of we will discuss tomorrow. That is called angular momentum. You tell me what is dimension of angular momentum. Angular momentum is denoted by letter L and it means linear momentum into perpendicular distance. What is angular momentum? Linear momentum into perpendicular distance. Linear momentum dimension you already know. This is mv into r. That means m1. L1 in velocity 1 is there. This is L2 and t. This is minus 1. So m1 L2 t minus 1 is the dimension for angular. Which one? Angular momentum. So this is all about the various types of the physical quantity, how to form these dimensions. So that's why students, again I am giving you some assignment today. What is your assignment? Whatever quantities are mentioned in your NCRT or whatever material you are having in unit and dimensions, there you will find a table. In most of the material it is given. Just you have a look on this table and try to read that only, whether you know this formula or not. Most of the things we covered in today's class, rest things we will cover in tomorrow's class. That's why, yes, be consistent in classes and try to solve the questions. Otherwise, whatever topic we have discussed, if you not revise that topic, definitely you will forget all these things. That's why your time should be utilized properly. So you try to revise whatever concept we discuss. Okay, dear friend, thank you very much. Jai Hind.
वो by mistake हुआ, वो गाना, वो second video